So the most important application for lithium-ion batteries is for electric vehicles. The problem is that the batteries are too expensive and too heavy. So for the Ford F-150, for the electric version, it's 2,000 pounds extra, $10,000 more. That's too much for the low and mid-price cars that are going to drive the transition to electric vehicles. So we have a series of materials that fix this problem. The first is on the anode side. So we replace microparticles of graphite with microparticles of silicon. So when I say microparticles, you should think easy to process, compatible with the existing way of making batteries and battery materials. That's really crucial for how we commercialize and scale up quickly and cheaply. So silicon is a better material than graphite. It's half the cost on a per kilogram basis, but it's got 7 times the capacity. So it's 14 times cheaper, and it makes the batteries smaller and lighter, so more valuable. So our products, we sell a silicon powder and a few other things that make up the anode. We have a proprietary electrolyte that's a liquid sold in 55-gallon drums. So we sell the materials, not the batteries. The cell components market is $235 billion in 2030, according to McKinsey, growing 10x after that in the next 20 years. So everyone is interested in silicon, but it's got a huge problem associated with it. So as the battery charges, the silicon expands. There's a layer that forms on the surface. That layer causes the silicon to break apart. The battery becomes useless after a few cycles. So one way to solve this is to use a very exotic form of nanosilicon that's orders of magnitude more expensive, and it ruins other aspects of battery performance. So we took a different approach. We said we want to form a protective layer on the surface. So we have a proprietary electrolyte that enables the particles to cycle in a very stable manner. So we are currently making pouch cells. We're making coin cells. We've scaled up to these pouch cells. The pouch cell is the format that the car companies want to test. So we have car companies waiting to test these. These are the names you know. So we have a team that's set to deliver. We have decades of experience in advanced materials and entrepreneurship. We have 2 IPOs. So how do we get to market? So next year, we'll start selling the pouch cells as an easy way for the car companies to test. But ultimately, we want to sell materials. So we'll go to material sales in 2026. The car companies will buy the materials from us. They will make the batteries with their cell manufacturing partners. We are going to outsource the manufacturing. So we're not going to build our materials. We're going to have a partner to do that. We'll be at pilot scale with that partner in 2026. We'll be at commercial scale in 2027. We'll get to a supply agreement with the car company. And then in 2028, you'll be able to go to the dealer and buy a car with AquaLith materials in it. This is the first model with the first car company, additional models, additional car companies thereafter. And again, because of the compatibility with existing manufacturing, that enables us to scale quickly and cheaply. All of the other new technologies involve massive changes to the way that batteries are made. So we are raising $3 million. We have already raised $2.4 million. We have $600K still open. We're using a safe with a $9 million post-money cap. And again, the use of funds is to begin qualification with the EV makers. So together we can power the future. Thank you, and I'll see you in the breakout room.